Mentally Math!
Let's get mental!
Alright, welcome back. Happy New Year! Alright, I'll let everyone get a little bit ahead of me. We know the drill.
Yes. I like the drill.
Oh, good. I'm glad that you like the drill. So today we're doing plotting functions, and it is pretty simple. Pretty quick and simple today.
Okay, I'm done.
Okay, all right. Okay. That sounds like I should get started then. Alrighty. So then this we could just say, well, it's like 30 times 20, 3 times 25 with a 0. So we can say that's 75. This one we're dividing by 10. So one boingy to the left, boingy. And so then that will get us 0.025 or 25,000. Little algebra. 40 minus 4 is 36 divided by 3. So x equals 12. Then,
I thought it was hard, but then I realized it wasn't actually that hard.
oh yeah, it's really super simple. It's definitely mental math. And then metric conversions. Okay. So this is just times 100. So 5/10 would end up being 50 centimeters. 100 centis in a meter, so half of that. Okay, so with our exponents, this is actually 625 minus 225 equals 400.
Oh, do you know what I did?
What'd you do?
I did something else. What did you do?
Please, explain.
Wait, never mind. I thought
Okay.
I did something else, but it was the same thing.
Okay, cool. All good. Okay, then 7 times 5 is $35. Dollar bills. Then 2 pints is what fraction of a gallon? Well, 2 pints is equal to what?
1 quart.
Huh?
1 quart.
1 quart. And quart, like a quarter of something is
1 quart.
1/4. Ta-da. Okay. Seems like even the mental math is kind of chill today. Alright, so then square 9, that's 81. Minus 1 is 80. Divided by 2 is 40. Minus 4 is 36. Square root is 6 times 3 is 18. Plus 2 is 20. Divided by 5 is 4. Square root of 4, that's kind of funny, really. 2. Then minus 5 is negative 3. So someone thought that I should do the spirals backwards for this, since it's a negative number. So, or no, I guess that would be more like, woo. Okay.
That looks messier. So
Yes.
No offense.
Oh, well, none taken.
It just looks messier than the ones you do.
Okay, all right. Okay, so yeah, we know about functions. Let's talk about them a little bit. So Jamal is ordering chairs for the furniture store. The function table shows the number of chairs he orders for each table. He's about function tables, right? Anyway, there's a dad joke in there somewhere. Tables.
Oh, I get it. Function table.
It's the function furniture store where they have function tables. Something like that.
I get it.
Okay. So write a rule. So looking at these, so we got our input X and our output Y, and so write a rule in words that shows the number of chairs Jamal orders for each table. Okay, let's just start with that. So everybody, write one down. I'll call on 3 people, and I see you 3 right there. Okay, you were first. So, okay, I'll let you finish writing now. You seem eager. Okay, did you write down your rule? Okay. Write down a rule. What? And keep in mind, there's another one for writing an equation. So this should be in words. Like you should be writing it in a sentence in language.
Okay.
The C is for writing it as an equation. So you should be writing a sentence. Yeah. We got that last class. People started writing equations to explain, but we got a whole nother question for that.
Okay, well, I'm just gonna keep what I wrote for C.
Yeah, sure, of course. Just put a C. Just this time C goes before A. All right.
ACB.
Okay, I'm letting. I see pencils and pens still going. I'm gonna let everyone. I mean, you can just look at it. It's very mentally mathy. Okay, and I already have my 3 people raise their hands really quickly. Are you 3 still wanting to?
Yeah.
Either one. Okay. All right. So what did you do?
I did y is x multiplied by 4.
Okay. There. Okay, let's start here with a few pom poms. And what did you write?
I did the same thing, but I just said I just gave an example saying 1 times 4 equals 4, then 2 times 4 equals 8. So I did the same thing that Anne did, but I just said that as an example, I did 1 times 4.
Well, all of your answers are going to be the same answer with different phrasing.
Yeah.
So yeah, of course. Okay, and what did you say?
Pretty much the same. I just said 1 table that is ordered has 4 chairs.
Okay, sure. Okay, could you repeat that a little louder one?
1 table that is ordered has 4 chairs.
Okay, sure. Or maybe you could say for every table that is ordered, there should be 4 chairs, or something like that. Okay, cool. All right, so completing the table.
Dude.
So, dude, all right. So everyone, just tell me what's 5 times 4? Ready?
20.
Woohoo!
Can we just write 20, or do we have to draw the table?
No, you could just write it 20. You don't have to do anything. Okay, so writing the rule for function table. Now, there is a format for this. Some people wonder why it has to always be like this. Like, you could write it in a different way, and you would be mathematically correct, but you wouldn't be doing it in the format. Sort of like, it's kind of one of those, capitalizing the first letter of a sentence sort of thing it's like that, so everyone's kind of doing it the same format kind of thing. So it's always y equals whatever you're doing to x. Like my whatever squiggle. So that is so see if you can write a function rule where it's y equals, then what do we do to x? What do we do to x? Okay, so what do you think the answer should be? Ta-da! Yeah. That's it. You're done.
I thought that would be.
Boy, that's like a 3 pom-pom. That'd be more to it? No, these examples are really simple today. Really simple, huh? No. Nope. Well, let's see what you're doing there. Oh, yeah, okay, sure. But this is kind of your algebraic term. She was wondering if you could do that. I think that's a kind of a. Also, you're not wrong, but if we're gonna be sort of doing formulas and doing algebraic expressions, we can just assume if x is next to a number, you're multiplying them.
Oh, okay.
Okay. All right, so let's talk about this next function table a little bit. Aha! So take a moment. Let's stare at this for a second. What's the formula here? Yeah. So everyone, see if you can write the formula for that, and then we'll just check ourselves. There's a little more to it. Yeah, we're going to plot it on a graph. We're going to do some graph plotting. Yes. This is the main event of this lesson. Is we are going to graph this.
Graphing plots or graph plots.
Okay, so want to get an easy pom pom here. What is our rule?
X is equal to 2x. I mean, y is equal to 2x.
Yep, there we go.
So like times it.
Yep, there we go. Y equals 2x. Okay, so that being said, and now that we've got our formula rule, let's make a graph. Now the good news is you do not need to do any negative numbers for this.
Is it usually a line graph?
Yes. Yeah.
So
Yeah.
can we just do like, instead of like a cross, can we just do like 2 lines?
Sure. I'm sorry. I was just force of habit. One. Yeah.
I have a question. So for the rule, for the first one, 1 times 1 isn't 2.
2 times 1 is 2.
Oh, I thought like 1 times 1. Okay, yeah, never mind.
It's okay.
Well, I just drew a random line, and by luck, it was exactly 10 of those boxes. So I couldn't
Oh, that's cool. 6, 7, 8. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8. So I'm assuming you're going to go faster than me because these are coordinates, right? And of course, 0, 0. What's another way you could say 0, 0?
Or the or.
Oh, but Blurty McBlurtison killed the reward system. So please don't blurt the answer, or I cannot give rewards for that.
Can you give a reward if you knew it? But
Nope. Nice try. Okay, so let's plot these coordinates. So we've got 0, 0, the origin, as mentioned, as blurted, and then 1, 2. Okay, then 2, 4. It's a very steep graph. And 3, 6. And then 4, 8. And I'm gonna warn you that my program here is just, my app here is just absolute rubbish for this part. It just does not want to put it right where it's supposed to be. What?
Do you have to put like a line through then? Yeah,
If you're graphing it, yeah.
Okay.
Sure. If you're graphing it, then it's a line.
I noticed that it's always like an upward slope.
Ooh, yeah. Well, there are variations.
Well, some of them are downward
Yeah,
slope,
it depends on the formula.
but usually it's always a straight slope.
Uh-huh.
It's like a plus 1 minus.
Well, there can be, I believe it's called a sine
Yeah,
slope.
those
Yeah, these can get a little weird, but not today. All right, let's see if this will give me a decent. I mean, it's not totally terrible. Let's see if I can get. Oh, perfect! Wow, I can't believe that actually worked.
Really cool.
Yeah, and it's actually more accurate than my dots. Like, it is actually going through the intersection points on the graph better than I put my dots down on the intersection point. Okay, well, I'm
Good job.
Oh, thank you. Okay, I'm feeling really good about this. All right, so plotting function tables. That's pretty much the lesson.
Wait, that's it?
Well, there's one more thing we're going to talk about over here.
There's one more.
Not that much to it, though. Okay, so we're going to do two things here. I will make this bigger so we can look at it. So, two things is we will write the coordinates, find 3 coordinates on the line that can represent the function, and then using x and y, write a rule for it. And we'll also, I will also write down the coordinates. Okay. So, and I guess for you, I mean, unless you want to draw this, which you really do not need to do, you could just write down the coordinates that would be kind of your function points. So if you're wondering what I mean by that, it's like, so we're going to look here and try to find the places where it's at an intersection point. Because, I mean, this right here is an actual value, but it's not simple.
So an integer value.
Yeah, but integer values are kind of simple. So I can go, oh, okay, well, let's see. This one's at an intersection point. And that one's at an intersection point. And then following the line down, oh, that one's at an intersection point. So those are my 3. It looks like this one is too, but we don't need it. All right, and so I'm gonna write these.
Which one would be intersection?
Because it's where two lines intersect. Right? You see there? That's where two points, like two of the lines on the graph intersect. Like, you know, it makes a little cross. Right? So like right there. As opposed to say like this right here, like it's sort of in the middle. It's like halfway between here and here, right? So that's not really good to use.
But do we
I mean, it is a value that you could figure out, but really, like right here, you know, it's where 2 and 4 intersect. Right here is where 1 and 2 intersect, and so forth. So those are your best ones.
But what about but 0, 0 is also getting into.
Ooh, yeah, we can do 0, 0 too. Sure, 0, 0 could totally be one of your points.
But it only asks me to use 3. But that counts, right?
Sure, it counts. Sure. In fact,
The book used it.
Oh, really? Okay.
Oh.
It seemed kind of seemed sort of obvious, but yeah. And okay, so here I'm just gonna write down my 4. So we've got -2, -1, 0, 0, then 2, 2, 1, and then 4.
Mr. Presley, didn't it ask for 3 points?
Yes, but I'm breaking the law. I'm gonna do 4. No one can stop me. Okay, yep, I'm going to math jail for that. Yeah. Okay, so looking at this, who can figure out there's actually 2 ways this could be stated. If you have already looked at it in the book, please don't answer out loud, because that's, so what would be a couple of different ways, people not looking at the answer in the book, what are a couple of different ways this could be expressed? And I'm hoping for someone that hasn't gotten a pom-pom yet. What?
Y equals half times x.
Boom! Okay, you're looking at...
No.
Okay. Yeah, y equals 1/2 times x. That's one of them.
I was just looking at the graph.
That's a big guy.
You're so fuzzy.
It's a big fuzzy one. Okay, and then who hasn't got a
I
pom?
haven't looked at it so far.
Okay, what?
I haven't.
Okay, so what do you think?
I think it's y. Wait. Does y equal the rest number for half? think it's correct there. Never mind.
Wait.
Never mind. I was going to say 2x, but it's
Oh, no, it's not 2x. It's just another way of expressing
Oh, no, I know.
1/2 x. Yeah.
X over 2?
Yes, very nice.
Oh, that makes sense.
Because it's x divided by 2.
Oh.
Right? So 1/2 times x would get you there. Also, x divided by 2 would also get you there.
Wait, mental pressure? I don't know.
Huh? Because your here. Your y. I don't think that's doing that to the recording though. Oh boy, we just gotta make it to tomorrow. I'll bring my cable. So basically your x coordinate your y coordinate is always 1/2 of your x coordinate. So you could say that you could multiply your x value. So say for the first one, you could say if we're looking at, well, let's look at the 4 too. So if we were to plug that into this, we could say 2 equals 1/2 times 4 over 1, right? And, well, a little cross-canceling goodness would get you to 2, right? So that's if you're multiplying by 1/2, or you could say it is 4 halves, and that equals 2.
Yeah, but I don't get how y equals 1/2 times x.
Okay, well here, 1/2 times x because anything. Well, here I'm showing here. So 1/2. So x. So over here, x is equal to 4, right? So 1/2 times 4, right?
I think I know how I can explain.
So that gets you to 4 halves, which equals 2. So that's how you get your value of 2 for your y coordinate.
I think there's another way to explain, Mr. Becker.
Okay, well, yes.
Well, you could give a value to y and x. So let's say for y it could be so trying to multiply. So pretend it's x over 4 and then y. So y could be 8 and then something over x. So some x. Oh my god.
Well, we're trying to kind of simplify the concept here. Yes.
There's a simple rule for this.
Mm-hmm.
So anything multiplied by any integer multiplied by a fraction is that fraction of itself.
Right. So if you multiply something times 1/2, it's saying what is 1/2 of this number. So say 1/2 times 4, it's asking what is 1/2 of 4.
Because there's certain words that go with math. For example, which is basically multiplication.
Okay, and then for this one, I mean, if you just plugged in the numbers, y equals 4 divided by 2, which actually gets you all the way to the second step of the first one, right?
I get it.
Okay, awesome. Which gets you to y equals 2. Okay, well that's good. I'm definitely be sure to stop me if it's not totally clear. Okay, we all good? All right, I'm going to stop this.